Greetings all. Today I want to go into a little detail about the HP LED matrix displays and how they work, and then get into the code I wrote to operate them. The way these are set up, there's 4 characters, 5x7 LED matrix for each character. And as we can see here, we have a 28-bit serial in, parallel out shift register. These are all the data bits here, and those are replicated on the other 3. Then we have a constant current syncing LED drivers. Here's your matrix, and then you have the column enable pins, or the column enable lines. Like columns in each display are connected in parallel. So if you say activate column 1 in each of the 4 positions is active. So the way this works is you shift in data, the data you're going to display, you'll shift into here. This will go into the 28-bit shift register. Now the way this is set up, you'll put the 7 data bits for position 4 in first, followed by 7 bits for position 3, then 7 bits for position 2, and finally 7 bits for position 1. When you take shift all of those data bits in, then you can take one of the column enable pins high, and whichever column you choose will be displaying the data that you just shifted in. Now, if you take all 5 of them high, of course you're going to get the same data on each column in each of the displays. So when these are in normal operation, you'll shift in 28 bits, take one of the columns high, display that for some period of time, turn that off, hit the blanking input, taking it active, shift in your next 28 bits, take the blanking, disable the blanking input, and then take, say, column 2 high. Display that for some period of time, turn that one off, hit blanking again, shift in the next 28 bits, so on and so forth for columns 3, 4, and 5. Once you get all 5 columns displayed, then you go back and shift in for column 1 again and run through the whole process. If you do this quick enough, it looks like all 4 displays are operating simultaneously. And you can see that if I turn over here to my development board, you'll see the display right up here, and if I turn this on, you see that it displays the data. Now there's some interaction between the camera and the display, so it's not exactly the easiest display to see in this case, but take my word for it, it works. So that is basically displays are set up. And as I was saying before, here's the blanking control pin. Whenever you're shifting data in, the blanking pin will be taken active, and that prevents any spurious displays on the matrices before you're actually ready to display anything. Then, in addition to that, to display the data, in my case, I want to display the digits 0 through 9 and the letters A through F for hexadecimal data. So to do that, I needed a font file, a 5x7 matrix font, and I found that right here. So as you can see, we have digits 0 through 9, and here we have letters A through F. So what I've done, excuse me, what I've done is, let's say I want to display a 0. This will be for column 1, column 2, column 3, column 4, and column 5. And if I convert these columns to hexadecimal data, here, this will be the least significant bit. This is the most significant bit. So I have 0111, which is E, and then 110, which is 3. So I would shift in 3E into the 28-bit shift register for whatever position I wanted it. Let's say I wanted it on all 4 positions. I want to display 0, 0, 0, 0. So I will shift in 3E 4 times. That will put 3E in position 4, in display position 5, or 3, in display position 2, and in display position 1. Then if I take column 1, pin high, that will display this first column. Okay, then the second one is 1010, which is 5, and then 001, which is 4. So the next column I would shift in would be hexadecimal 4, 5. And then when I get 4 of those shifted in, I take column 2 high, all the other columns are low, take column 2 high, and that will display the second column. The third column then will be 1001, 001, which is 4, 9. Shift that in and take column 3 high, then take it low and shift in 1000, 101, which is 5, 1. Shift that into all 4 positions, take column 4 high, wait a while, turn that off, and then I go back to 3E again because this is 3E here. And then the same for all the other characters. Like in this case, a 1, the first column is all zeros. And then here we have 1000, 010, which is 21. Here is 7F. Here is 01, and here is 00. I do that for the rest of the numbers and for A through F. So what I've done is I put these in a file or in an array within the program, and I store that in EEPROM. Where did my array go? Well, I don't see it. Doggone it. That's irritating. Ah, here it is. It's gotten wrinkled. But here you can see for 0 is 3E, 45, 49, 51, 3E. For a 1 is 00, 21, 7F, 01, 00. For a 2 is 21, 43, so on and so forth. I put these in EEPROM. Now what I will do is my program will take a hexadecimal digit input and it will use that as an index into a lookup table. The lookup table gives me the beginning address in EEPROM of that character. So let's say I'm going to display a 3. So the first 5 columns are 0, next 5 are 1, next 5 are 2. So 3 will start at 0F and continue for 5 bytes. 0F, 10, 11, 12, and 13. The program then takes this data and breaks it down and shifts it out bit by bit into the 28-bit array of the display. Then it gets the second nibble, converts that to hexadecimal, uses that as an index into a lookup table. That lookup table then will point to where in EEPROM the next character is going to start at, so on and so forth. Once these characters are chosen, or the data for the characters is found, they are stored in, that data is stored in local variables, so that when all the data is displayed, you can go back and recycle until that data is changed. Once the data is changed, like say a new address is detected on the bus, or new data is detected on the bus, the display controller will pick that up and send it to the display, so the display will follow along very quickly. My next video will be going over the actual code and how it works. This was a basic introduction, and just to illustrate or describe what the process is. So, in a nutshell, the PIC that I've used as a controller watches the data bus and the address bus of the ELF2. It pulls off the data from each of those 2 buses, stores it in memory, uses that as an index into a lookup table. The lookup table then tells me where in EEPROM to get the data to display that hex character. That data is then stored in local variables in the program. The program then takes that data apart, stores it in a form that made it easier for me to troubleshoot if I needed to. Shifts it out to the displays and displays it, and then goes back and does the whole process again. So until my next video, which will go over the actual software, That will end this one. If this is interesting and you want more, please leave in the comments any comments you may have, good, bad, or ugly. I'll go over all of them and try to follow any suggestions for improvement. Until then, adios.